Problem number 12. Steel ball bearing bounces vertically on a steel plate. If the speed of the ball just before a bounce is vi, the speed of the ball immediately afterward is vf equal alpha vi, where alpha less than 1. Which one of the following graphs best shows the time between successive bounces tau as a function of time t? Solution for problem number 12. If speed right after a bounce is vi, the total time tau I will be 2vi over g. And we can express vi through v initial v0 multiplied by alpha power I. So it means that total time tau I equal tau 0 multiplied by alpha power I, where tau 0 equal 2v0 over g, where v0 is initial speed. Now let's count what is total time ti. That will be sum of tau n from n equals 0 to I. So which is tau 0 multiplied by this sum. This is a partial geometric progression, so we have this result. And finally we have time t as a function of time tau. Now we just need to express time tau as a function of t. That will be tau equal linear function with a negative slope. And if we look at all these 5 graphs, we see that only graph B has this property. So it means that B is the correct answer. And this was a solution for problem number 12. Problem number 13. A juggler juggles n identical balls, catching and tossing one ball at a time. Assuming that the juggler requires a minimum time big T between ball tosses, the minimum possible power required for the juggler to continue juggling is proportional to next one. Solution for problem number 13. If total time between tossing is big T, total time for ball to travel equal number of balls n multiplied by big T. But from other hand, this time equal 2v over g, where v is speed of tossing ball. Now we can count what is kinetic energy needed to throw this ball. Now we can count what is this speed v. That will be gt over 2 multiplied by n. And to count what is minimum possible power, we need to find what is kinetic energy for one ball to throw and divide it by time big T. That will be total power. Finally we have power P equal kinetic energy for one ball divided by time between two balls to throw, which is mv square over 2 big T. And we can use this V found in previous formulas, and finally we have power P proportional to n square, which is answer C. And that was solution for problem number 13. Problem number 14. A man standing at 30 degrees latitude fires a bullet northward at a speed of 200 meters per second. The radius of the Earth is 6,371 kilometers. What is the sideways deflection of the bullet after traveling 100 meters? Solution for problem number 14. Here we have deflection due to Coriolis force due to rotation of Earth. And this Coriolis force equal to cross product of negative 2 omega with the velocity of bullet, which is minus 2 omega v sine theta, where theta is latitude 30 degrees. means the 2 and the sine theta, which is 1/2 cancelled, and finally we have this result, which is 0.0145 meters per second square. That's the acceleration due to Coriolis force to east. To east because omega is going to north and V is going to north with the angle 30 degrees deflected from north, which is going to west. But because it's negative, it's going to east. Now when we know what is acceleration, we can find what is deflection. First we can count what is total time for bullet to travel. That will be distance 100 meters divided by speed of bullet, which is 200 meters per second. So total time is half seconds. And now we can find what is deflection. That will be 1/2 a t square. And after putting numbers, we have 1.8 millimeters to east. That was answer D, and that was solution for problem number 14.